Hello class, Mr. Stone here. The problem we have today that I found online, it's addition of radicals, okay? What I did here, I put up parts of a radical, okay, on the left-hand side, okay, right up the top here. Let's circle that so you can see it, okay? So I'll just start from left to right, okay? The number outside the radical symbol, okay, is called the coefficient of the radical. Okay, see right here? It's a number 5 here. Okay, now, inside the radical symbol, okay, is the index. Okay, now this shows a 3 right here, 3. Okay, if there was nothing written there, okay, it would be deemed or implied that it was a 2, because this is a square root sign. Okay, so now inside is a radicand. Okay, and on this one it's 7. Okay, so those are basically the parts of a radical. Okay, so just kind of familiarize yourself with that. Okay, they're good to know. Okay, like on the index, you're going to see no number a lot of times, and then you're going to see a 3, a 4, a 5. It could be anything. Okay, sometimes even inside, they'll put on the radicand, they'll square that or cube it. Okay, so they confuse you a little more. Okay, but hey, once you kind of learn it, you're going to say, wow, this is kind of easy to do these. Okay, hey, let's go down and do the problems. Okay, it says add the following radicals. Okay, it's right here. Okay, so now what you have to have when you're adding these, the radicand has to be the same to add these. Okay, so we'll start the first one. It's 3 to the square root of 5 plus the square root of 5. Okay, but now there's nothing written outside that square root of 5, but as like even when we're adding variables, if you're adding 2x plus x, it implies there's a 1x there. Okay, so we can put a 1x here. We can put a 1 here. Okay, so now it's 3 to the square root of 5 plus 1 to the square root of 5. That equals 4 to the square root of 5. And that's my answer. Square it off so the teacher knows, hey, that's my answer. Okay? And that's all there was to it. Now, we move down to the next one. And just like I said, the radicand's got to be the same. And you notice they are the same. They're both x's. Okay? So we got 2 to the square root of x plus 7 to the square root of x. That equals 9 to the square root of x. And that's it. This is relatively easy. Okay? Now, as you notice in number 3, okay, you have the square root of 12 plus 7 to the square root of 3 plus square root of 75. Now, the radicands aren't the same. They're all different. Okay, so what we have to do on this one, we have to get them to all the same. Okay, our job is to get these the same. Let's erase this and give us a little space here. Okay, go back to the pen. Okay, so how I kind of like this, I'm going to rewrite this. Okay, I'm going to rewrite the first one. 12. Okay, what I like to do here, I like to do a tree off this. Okay, now, because this is an even number, I know I can divide by 2. Okay, so I'm going to go like this. I'm going to go 2 and 6. I know I can do that. Okay, now on this one here, I can make this a 3 and a 2. And that's what I got. Okay, now to simplify this, okay? To simplify this, I'm looking for pairs because this is a square root sign. If this was a cube root, I'd be looking for 3s. If this was a fourth root, I'd be looking for 4s. What I got here, though, at the end, I'm just looking at the end ones, okay? What I got here, I got a pair of 2s, okay? And I got 1 3 here. So what that tells me, outside on this one, okay, I got 2 to the square root of 3. And that's it. That's simplified, okay? Now, let's go to the next. The next is plus 7 to the square root of 3. Okay? 2, 3. That's it. I can bring that down. Because that's, got to the 3 is going to be the new radicand that I want. So I got 7 to the square root of 3. Okay, now let's go over the next. I got square root of 75. Okay, so hey, how can we break this down? Well, hey, I know I can go 3 here, okay, and I can go 25 here. Now, can I break the 25 down? Sure I can. I can go a 5 and a 5. Hey, I quickly see I got my pair. I got 5 here, okay, and the 3's by itself. And kind of that's what I wanted. So this is plus, I put the 5 outside, okay, that's the new coefficient, and the 3 is a radicand. So, hey, they're all the same, okay? So now what do I do now? I can add these together because I got all the radicands are all the same. So I got a 2 and a 7 is 9, plus 5 is 14. So 14 to the square root of 3. And that's my answer. Square that off so the teacher will say, wow, hey, you get the right answer, okay? But you see how I broke it down with the trees? And what I'm looking for, because it's square root, I'm looking for pairs, okay? And of course, I was looking to get the same radicands, okay? And I was able to. And 3 was the number I wanted, okay? Might not be 3, might have been 4, might have been 5. Who knows what they would have been? But I was looking to get the same radicands inside, which I did do, and I got 3. And I was able to get the pair forms the new coefficient, okay? And that number forms the coefficient, which was 2 in the first one, 7, which I was able to bring down, so I didn't have to do anything, and then 5 in the third one. And that was it. Hey, that was easy, okay? Hey, let's move on to the next one, okay? I'm going to erase this, okay? Erase this all, and we'll move on to the next one, guys. And remember, you can find online, you can find some of these, and actually practice with them, okay? And the more you do, okay, the quicker you're going to be at this, and you're going to spot these and say, oh yeah, I can break this apart like this, okay? This is what I'm gaming for, okay? I can break it apart, okay? So hey, let's do the next one, okay? So we got 3 to the square root of 8. How can we break this down? Well, we know it's an even number, so we can go 2, and we go 4. We already know that. Let's break this apart. We got a 2 and a 2. Hey, I can quickly see I already got a pair. Look at this. I got 2 as a pair, and I'm going to end up with 2 as my coefficient. But now I got a 3 in there already as a coefficient. So what do I do now? I take the 2 and I multiply times the 3. Okay, so I take this and I multiply. I'm using an X here, but I should have used a dot. I like using the dot better, but they're both the same to me. Okay, a dot and an X, but just in case the variable is an X, hey, let's go back to the dot. Okay, so 2 times 3, I get 6 to the square root of 2. Beautiful. Now, let's bring down the next one. So it's plus 2 to the square root of 50. Hey, so let's break this apart. We'll tree it off. I got a 2, and I got 25. Tree this one off. I got a 5 and a 5. So hey, I already know okay, so I end up with 5 times 2 is 10 to the square root of 2 plus, okay, now I got the same radical sign, radicand in both. I got 2, so I got 6 plus 10 is 16 to the square root of 2. And that's my answer, okay? If you like this video, give me a thumbs up. Subscribe to my YouTube channel. It'll help my YouTube ratings. More students will see this, and hey, they'll get a better grade, okay? And that's what it's all about, okay? This line here, right? I'm looking at this. Let me erase this for a second. Erase this. Fine tip. this time sign should have been from here. Okay? Right there. Okay? These should have went together here, like this. Okay? So that's how it should have went. The 2 times the 3 is the 6. Okay? Because the one that goes by itself is a new Radican. Okay? I drew the line the wrong way. I just looked at it. Okay? So if you like this video, give me a thumbs up. Subscribe to my YouTube channel. Show this to any mathematical students you know, because they can get a better grade if they learn how to do this addition of radicals. They're going to see this in school, and they're going to say, oh, yeah, I remember how Mr. Stone formed these trees, and he got the radicans for each side to be the same. Okay, now I understand the parts of a radical, too. Okay, thank you very much. Have a great day. Bye-bye.